Makes sense.
Okay. So there's your axis. Where's my force?
Dorsiflexors. Because gravity's pushing you down.
So gravity is pushing you down. So what is that going to cause you to do?
Plantar flexion.
Nope. Because plantar flexion is a matter of pointing your toe, right?
Okay.
So if gravity is pulling you down, that is going to cause that dorsiflexion. Do you see that? Does that make sense?
No.
Sometimes it's easy to get them reversed.
It is. Especially because you have to think as if you were not like on a surface, basically. You have to ignore the floor. So maybe it'll be easier if we first look at resistance.
Okay.
So the resistance in this case is the center of gravity. So the center of gravity is going to be pulling where there is the most weight with regards to this. So your whole body weight is going to be focused right here.
Coming down through your heel.
Mm-hmm. So that's going to be your resistance.
Why is it not on the toes, like where you're touching the ground?
Because most of your weight, because the center of gravity is basically the balance of the weight. Because here you do have weight on your feet, but the ratio of that comparatively to your body is very, very small. So it might move it slightly over a little bit just to create that equilibrium. So it's like a sword. So like when you're trying to balance it, you're not going to place that in the middle. You're going to place that close to the handle to balance it, because that's where its center of gravity is. Does that make sense?
Yeah, sure. I think so.
Did my sword example make sense?
Mm-hmm.
No.
To me it did.
So if I have my blade, and then I don't even know what this is called, but I always think of Pirates of the Caribbean when he balances it on his finger. He places it right here. And if it's perfectly balanced, that's like the best sword, according to pirates. I don't know if that's true or not, but and that's because this is the center of gravity, because this weight balances this weight. So that's the center of gravity.
Okay.
So that's what this is doing, but your whole body is the weight that's being pushed here, whereas here it's just your toes. Your toes don't weigh very much comparatively to your whole body.
Okay.
That makes sense. Makes sense. So we have our resistance. Where's our force?
Is it, so you said that my toes are going to do dorsiflexion.
Yes. So with this resistance, gravity is going to be pulling your heel down. If it's pulling your heel down and you don't have a surface to stop that,
That's what.
what are you performing?
So when I do that, it's gonna make me want to do dorsiflexion. So isn't it my plantar flexors?
Mhm.
Okay.
Yep. Does that make sense?
Uh-huh.
Okay. So where are your dorsiflexors? Insert.
Not plantar flexors?
I meant plantar flexors, sorry.
Okay, so we said dorsiflexors
Yeah.
are.
So dorsiflexors, bring your foot up. Plantar
So they're on
flexors,
the
bring them
front.
down. Yep. So dorsiflexors are on the front. Then plantar flexors got to be on the back.
Are gonna be on the back.
So that was like the soleus example.
Yep.
So it starts like on the heel or something.
Yep. So that's going to be the force.
Why isn't it your toes?
For your force?
Yeah, because okay, I don't see. Can you draw it out again like you did before concerning where it inserts?
Okay. So we have the tibia and fibula.
Yeah.
Okay. We have the tarsals.
Mm-hmm.
We have the metatarsals. Whoops. And then we have the phalanges.
Yeah. Okay. Fine.
And then one of your tarsals is your calcaneus, which kind of sticks out the back a little.
Okay.
Okay, so we have your soleus here. It's going to attach. So that's the insertion point, which equals your force.
Okay.
This is your ankle, the center of your joint. Nope, lied about that one. We are looking at the resistance here because that's where the body weight is pulling, right?
Mm-hmm.
So that's resistance.
Mhm.
The joint that you're looking at that's moving because of the force is right there. So that's the axis.
Oh, okay. That makes more sense. Okay.
Okay.
I see that.
Okay. Let's do this one. Okay, so here we have an arm, and they're going to be performing external rotation.
Why? It's kind of weird, like for like an exercise.
Mm-hmm. So it's a matter of being here, starting here, you're doing external
Oh.
rotation. So,
So this going like this.
yep. Okay. Where is my force?
Okay, so resistance wants you to do, I guess if you're starting here,
Well, because this is the motion you're performing, so it's going to want you to cause, the resistance will cause you to do it.
so it's just the external rotators that are the muscle group, the agonist.
Mhm.
Okay, so those insert at the top of the humerus.
Mm-hmm.
Isn't it okay? So if I'm doing this, right, this motion, isn't my force going to be the internal rotators though?
So if you're doing this, what is resistance tending to cause?
Right, to go back down.
Good, so that's an internal rotation.
Oh, so then opposite that is external rotators. Okay.
So when you bring it back to anatomical, that's an internal rotation. If you're here, you're going down. It's the same.
Okay.
Okay. Where is my where's my resistance?
Is it just like coming down to the weight,
No, because you have to take into account
that part of the arm?
that part of the arm.
So it's probably a little bit higher, so maybe like up in your forearm.
Okay. So when we're looking at this, we're looking more along a lateral sense, not so much a longitudinal. So it'll be more right or left than up or down.
Which one are we doing that? The axis or the resistance?
Resistance. So the center of gravity. Because if you're here or here, that's still in line with the weight.
Oh.
You see what I'm saying?
Mm-hmm.
So we're more evaluating this way. So there's a lot of weight here, not so much over here. How is that going to pull? Where is that going to make the center of gravity?
It's gonna be somewhere like up on your bicep or something.
Good. So is it going to be like towards the elbow?
No, probably the other way. That's the shoulder.
Like here or farther over?
I would think to the right.
To the right? How much?
Oh yeah, right there, maybe.
Okay. So when it comes to this, because I guess it also depends on how heavy the weight is. But if you have a pretty heavy weight, let's say it's 10 pounds, then depending on if you're a guy or a girl, I guess, also depends on how big your bicep and tricep are. But it'll only be slightly over, because the majority of your weight is going to be here. Right?
So wouldn't that mean it need to be more that way? Not towards the weight?
No, it would need to be towards the weight, because remember when we had the sword even? This part weighs very little compared to this. So that's why it's closest to the heavier part.
Yeah, that makes sense, yeah.
Balance it out. Okay, so this is our resistance. Okay, now where is our axis?
The shoulder?
Okay, so what are we rotating around though? Like if you think about the plane of motion that we're moving in,
Sagittal plane?
Transverse.
it's the transverse because it's rotational.
Oh,
right?
okay.
So because of that, it makes our axis right there. So it runs actually all up and down the humerus. And so in order for you to actually perform this motion, they say that the axis is always in the middle because it has to be between the resistance and force in order to perform that motion. Okay. So if it's a rotational movement, it is always this class system, which is
First.
first. Good.
So all rotation movements is going to be first class?
Correct.